All right, we are finally in Unit 3, and Unit 3 is all about still transformations, but one specific transformation, which is dilations. And the reason we didn't learn about it in Unit 2 is because dilations is not an isometry, meaning dilations does not keep things the same. And so in this lesson, Introduction to Dilations, we'll see how dilations really does change shapes or in what parts do not change. So let's start with getting down the definition of a dilation. So a dilation is a transformation that produces an image that has the same shape as the original, but not the same size. So everything is the same, it's just we just made it either really small or we made it bigger. We're essentially scaling things up or down in dilations. So we can't say that side lengths are the same, but we could say angles are the same, and we could say proportions are going to be the same. So it's just like when you're editing a picture, how you can take the corner and just move it in or move it out, and the picture still looks the same, it's just getting bigger or smaller. That's exactly what dilation is. So we're stretching or shrinking the shape, and you produce a similar shape. Not congruent, because they're not exactly the same, but they are similar in the fact that it's the same shape, just either bigger or smaller. So let's actually continue on and get down a more specific definition of what similar really means. All right, so similar means two figures or two shapes are similar if they have the same shape, but not necessarily the same size. So it's not saying that all parts are exactly similar to each other, but as long as they really are the exact same heart, maybe just bigger or smaller, they are going to be similar to each other. And this last part, but not necessarily the same size, you can actually have two things that are exactly the same thing, so they're technically congruent, and they are also similar. So every single thing that is congruent, you can also describe it as being similar, because of course they have the same shape because they're the same thing. So now actually let's take a look at some examples so that it will help you better understand similar. All right, so here we have two hearts. And you can see that this bigger heart really is exactly the same shape as this little heart. So all we really did was we took it and we scaled it down. So this is an example of a dilation. And because these are similar shapes. So maybe you want to put yourself a check mark because yes, these are a dilation and these are similar shapes. Now let's look at this one over here. This one is not dilation. And a lot of you can tell right away, those are not the same shape. They look kind of similar, yeah, they're boxes, but this one is a cube and this one's a rectangle, so they're not similar. These are not dilations. It's not like I took this one, scaled it down, and got to this one. So this one is an example of something that's not a dilation. And you see this a lot when people are playing around with images, and they'll take not a corner, but just one of the sides and pull it out, and you can get to something like this. But that's not what dilation is. You're not changing only one of the dimensions, you have to change all the dimensions at the same time to scale it up or down. So this is not a dilation. All dilations include what's called a scale factor. And that is just telling you how much bigger or smaller we're going to make something. So the scale factor might be 2, and so we're going to take the original and make it 2 times bigger. Or the scale factor might be 1/4, and so we're going to take the original and scale it down to 1/4 the size. And you'll see that a lot with scale models. That's exactly what the scale factor is. It's saying, oh, this is a 1/10 scale model of the Eiffel Tower, because it just took all of that and scaled it down to 1/10. So it's just how many times bigger or smaller our image is going to be. And then you also have a center of dilation, and it's just telling you essentially where we are stretching things out from. So let's go ahead and finish up these. When something is dilated, everything is scaled up or down according to the scale factor. So everything is either going to become 2 times bigger or 2 times smaller, depending on what that scale factor is. So obviously, if things are getting scaled up or scaled down, everything's going to be getting that much bigger or that much smaller. There is 2 things that are going to be preserved. So the only things that are preserved are the angles. So if something was 90 degrees in the original one, it's still 90 degrees even after we scale it, regardless of what the scale is. And obviously the shape, because that's the whole definition of dilation, is the shape is staying the same. But everything else gets changed. So your side lengths, if it's 2 in the original and our scale factor is 2, then obviously it got 2 times bigger, and your new side length will be 4. So now let's take a look at how to actually do a dilation, how to actually scale something. So we start with the 2 things that we always need. We have our scale factor, and our scale factor is 3. So we're going to take our pre-image and we're going to make it 3 times bigger. And then we need our center of dilation. This little O here, that was my best way of doing just a center of dilation. So let's go ahead and color that in and say that that's our center. So now what we are going to do is we're going to take everything and make it 3 times bigger. But the reason we need a center of dilation is that tells us where our image is going to end up in the end, because we don't want to put it right on top unless we need to. So actually our image in the end, so there's the distance here, so our image in the end is actually going to be 3 times farther away. So let's actually measure that so we can tell exactly where we need to start. So this is 5 inches away. So that tells us that our image, after we dilate it, is going to need to be 15 inches away because everything becomes 3 times bigger. So let's see where that first point's going to be. So there we have 15 inches away. So we're going to take, essentially, this point is going to get dilated out to here. So let's do the other points now. So this bottom point is 8 inches away. So if we're going to dilate 8 by 3, well, 8 times 3 is 24. So this point is going to get dilated out to be 24 inches away from our center. So let's see where that is. So it's going to be about right there. And I know at home this is going to be a little bit difficult because obviously you're not using the same things, same tools I am. Just do your best sketch of this to follow along. And we have one last point that we need to do. Let's start with how far away that is. Okay, so that's about 16.5 away. So that means we need it to be 16.5 times 3 far away for that last point. So this point, when it gets dilated out by a scale factor of 3, is going to end up at 49.5 inches away. So let's find out where that is. All right, it's actually pretty far away, all the way down there. Okay, so now that we have the points, all we have to do is connect the dots. And hopefully we do this right, and then it should look about like this, except 3 times bigger. And there we have it. So this big triangle right in the middle here, and I'll erase this line, but you don't have to, just so you can see where the triangle is. This triangle is this original one, just dilated by 3. So everything's 3 times bigger. The side line's 3 times bigger. It's 3 times as far away from our dilation point. This side's 3 times bigger. But again, the shape is preserved and the angles are preserved. So like how this is a right triangle, or sorry, this is a right angle, this is also a right angle. Okay? And that's how you do a scale factor. Here we have another example, and our scale factor this time is a fraction, which means that everything's going to get smaller. And in fact, everything's going to become half the size. So we're going to take this shape right here and make it half the size. It's going to be half the size. Every part of it's going to be half the size. Also, it's going to be half the distance from our center right here. So we're going to do the same steps as last time, but instead of extending out 3 times as much, we're actually going to take the lengths and make them in half according to our scale factor. So first thing first is we just need to know how far away everything is. So this first point is about 31 inches away. So if our scale factor is a half, we need to divide 31 in a half. So about 15 and a half is where our first point will be. So let's find out where that is. So our first point is going to be right here. And you should be thinking, yeah, that looks about right, because since everything's going to be halved, our final shape should be somewhere right in the middle here, about halfway. So let's go ahead and try the other points. The next point is 36.5 inches away. Half of 36 is 18, so we're thinking 18.25 is how far away our initial point, our scaled point should be. So about right there. So let's continue on with the other points. Okay, that point was 35 inches away. So half of that would be 17.5. And please write in if I was wrong about that. The nice thing about this, though, is if you do get it wrong, you'll probably end up kind of seeing it in your final shape because it will look a little off. And our last point, that's about 40, so this is going to end up being right about there at 20. So remember, everything just got half. So all of these points are at halfway between these. So you actually technically don't even need to know exactly the measured distance. You could almost just take them and fold the paper in half and just be like, okay, there's the half of that line, there's the half of that line to get these. Now, once again, now that we have these points, we can just connect the dots. And let me actually use a different color so it's more clear. And there you go. And that seems actually about right. It's halfway in between, and we're taking everything, and it's just got scaled down, but the shape looks the same. Now let's take a look at how to find what the scale factor is with all of this drawing already there. But instead, the only thing we're missing is the scale factor. We have to figure out what that is. All right, so here we have a drawing. We have our center here. We have our pre-image here, and then we have the image that was dilated out here. And what we need to find is the scale factor. All we need to do is figure out how much this was dilated to get to here. Now, the first thing you should notice is we're going bigger. So we can actually measure almost any part of these shapes to figure out what the scale factor is, because everything gets bigger according to that scale factor. So if we wanted to, we could measure AC and then measure A prime, C prime, and then compare them to get the scale factor. Or we could do AB and A prime, B prime to get the scale factor. Or we could compare the distances from the dilation points to get the scale factor. All of those are fine. I think I'm going to choose measuring from A to C and the distance of A prime to C prime and comparing those. But again, you could choose any measurements, any length measurements, and compare those numbers to get what this scale factor is. So let's go ahead and take a look at what AC is. Okay, so I just measured AC, and I got that it's 8 inches. So now let's see what A prime, C prime is. And I got that it's 13 inches. So in this case, it's actually probably going to be some sort of nasty decimal or fraction that's going to end up being our scale factor. We need to figure out what you can multiply by 8 in order to turn it into 13. And you might be searching for some magical number, but it's actually really simple. You actually can just think about the fact that if you multiplied 8 by 13 over 8, that will give you 13. And take a second to look at that, because I know we're all kind of bad at fractions. The 8s would cancel out, so 13 is what would be left. So this right here is our scale factor. Our scale factor is 13 over 8, or you could leave it as a mixed number. And I apologize, it's not a nice round number. Probably in our books they'll give us some better nice round numbers to work with. This was just something I pulled off the internet. Okay? But our estimation was correct. Yes, it was number over 1 because our dilation got bigger. And that's it. That's all we had to do to find what the scale factor was. And again, it would work regardless of which measurement we use. So we could have done B to C and B prime to C prime and still gotten the same scale factor. And that's it for this lesson.